So yan, hindi pala naka-record yung aking lecture kanina. So I have to delete everything. Ulitin ulit. So discard ko muna to. Magandang araw. We have two topics to discuss for today. So tatapusin natin lahat ng topics involved to dynamics or yung BES 026. Alright, so let's proceed. Our first topic is called the equations of motion, normal and tangential coordinate. So this time, itatackle naman natin yung forces affecting the motion of a particle in normal and tangential coordinates. Okay? So, sabi dito, kapag daw yung isang particle is moving along a curved path, the equation of the particle may be written in the tangential, normal, and binomial direction. So, as you can see here, we added another axis, which is yung tinatawag nating binomial, denoted by B. Okay? So, there are forces acting on the particle. So, kung last time, ang pino-observe lang natin is the property of motion, this time, we also observe the forces affecting the motion of the particle. Okay? So, kung may nadagdag na axis, ano yung magiging epekto? So, sabi dito, note that there is no motion of the particle in the binomial direction. So, isang consideration natin is there is no motion. Hindi dapat gumagalaw yung particle on three axis. So, gagalaw lang dapat siya on the normal and tangential plane. So, hindi dapat siya gumalaw on the three axis. Kung ganon yung condition, we can use this relationship. The summation of forces pa rin is equivalent to the mass times of the acceleration. Okay? Now, if our forces is present on the three axes, therefore the summation of forces can be written as the summation of forces on the tangential axis plus the summation of forces on the normal plus the summation of forces on the binormal. And that should be equivalent to the mass multiplied by the tangential acceleration plus the normal acceleration. Okay? Take note, wala tayong AB. Okay? AB is equivalent to 0. We assume that there is no motion on the binormal axis. Okay, so as you can see here, may mga U, UT, UN, UB. These are just the units denoting the direction or the axis of each forces. Okay, so wala naman silang masyadong epekto but they are just there to tell us na dito naka-point out yung ating mga forces. Next, we can only use this equation, this relationship, if these three conditions are satisfied. So, number one, provided that the tangential forces causes the mass to accelerate tangentially. Okay? And the normal forces, the summation of the normal forces tends to move the mass with the acceleration equivalent to the normal acceleration. Okay? And the summation of forces on the binormal is equivalent to 0. If this is not satisfied, therefore, this formula cannot be utilized. This relationship is hindi mo pwedeng gamitin. Okay? So, the reason for that the summation of forces on the binormal axis equivalent to 0 is because we want to have no motion on this direction. Okay? Dapat static lang siya dito sa direction na to and hindi siya nag-move. Okay? So, if we remember that the tangential acceleration represent the time rate of change in the magnitude of the velocity, so kung maalala natin, if a particle has a given velocity, for example, ito yung particle natin, at ang sabi sa kanya, this is the velocity and he is traveling along this path, the given velocity is always the tangential velocity. Okay? There is no normal component of the velocity. Okay? So, if that is the case, therefore, the given acceleration is the rate kung saan itong velocity na to is nagbabago with respect to time. Okay? So, if the forces or the summation of forces acting tangentially acts in the direction of the motion, the particle speed will increase. So, if mag-add tayo dito ng certain force Ft, okay, and this has an acceleration at, if the direction of the force is conniving with the direction of the velocity, or in line with the direction of the velocity, therefore, we can say that the effect of the force on the particle is positive. Okay? The effect of the force on the particle's motion is positive. Kung yung ating force naman counteracts the direction of the velocity, let's say nandito yung ating Ft, okay? If the forces or the summation of forces tangentially acts opposite the direction of the velocity or the acceleration of the body, then we can say that the forces has a negative impact on the particle's motion. Right? Now, ganun din naman sa ating normal component. Ang The normal acceleration decides kung ano yung magiging direction ng particle natin. If the normal acceleration increases while the tangential acceleration decreases, ang tendency ng ating particle is to move inward. Okay? So, therefore, if the forces along the normal axis pushes the particle inward, we can say that the effect of the normal forces or the net normal forces on the particle is positive. Okay? So, ang sabi sa atin, these forces that causes the particle to go towards the direction of the center of curvature, in our case O, okay, is called the centripetal force. Okay? Kung yung ating forces is itinutulak niya yung particle papunta dun sa center ng curve, we can say that that is a centripetal force. On the opposite, if the forces is pushing the particle outward, palabas doon sa kanyang palalabas or palayo doon sa kanyang center of curvature, that is called centrifugal force. Okay? So, centripetal force in our case in this discussion is positive, whilst the centrifugal force is negative. Okay? Let's proceed with sample problem number 1. Sabi dito, determine the banking angle for the racetrack so that the wheels of the racing cars shown will not have to depend upon friction to prevent any car from sliding up or down the track. Assume the cars have negligible mass, a mass m, have a negligible size rather, a mass m, and travel around the center of curvature r with a constant speed b. So, ang sabi sa atin, we have to determine the angle of banking for the racetrack so that the wheels of the racing cars will not have to depend upon the friction to prevent any car from sliding up or down the track. So, ang sinasabi lang sa atin, ano daw dapat yung angle na to para hindi mag-slide outward or slide inward yung ating car without the friction. Okay? So, without the friction. Ina-assume natin na walang friction. Alright? So, nakadepende lang or kina-counteract lang nung angle. Basically, the weight. Okay? The weight counteracts the motion or the sliding upward or inward. Okay? Okay? So for the solution, first we have to consider the forces acting on the two axes, the normal axis and then the binormal axis. Alright? So the motion of the particle is perpendicular to the plane of this paper. So nandito sa point na to towards you. Okay? So, there is an acceleration na humihila sa particle inward, but there are forces na kumukontra sa kanya. So, if we take the summation forces horizontal, so sabi sa atin, the summation forces on the normal, say normal, Fn, should be equal to the mass multiplied by the normal acceleration. So, if this is our axis, therefore, we can say, ano yung mga forces acting on the normal axis? So, you have the NC, okay? So, meron theta dito, which is also this theta from here. Okay? Yan din yun. Sulat natin. So, ayan. Ayan. So, we have NC. And if we want to get the horizontal component of this NC, that would be sine theta, opposite the angle. Sine theta is equivalent to m, and our AN, take note that our AN is equivalent to the velocity of the car, v squared, over the radius of curvature. Okay? So, ilalagay natin yun dito. We have B squared over rho. Right? So, that is the equation for the summation forces horizontal. And ang sabi sa atin, the summation forces on the binormal axis should be equal to 0. Therefore, if we want to determine the forces acting on this, we have NC cosine theta minus mg, and that should be equal to 0. Okay? So these are the two equations correlating the motion of the particle, the mass of the particle, and the velocity of the particle. So so ang hinahanap sa atin is this theta. Alright? So, ang sabi sa atin, ang mga given, meron daw tayong mass M, meron tayong R, and then meron tayong B. The only thing that we don't have is the normal force, NC. Okay, so pwede naman natin tanggalin yung NC by equating this in terms of NC. We have NC is equivalent to MB squared over rho sine theta. And in here, NC is equivalent to mg over cosine theta. Alright? So, ang given sa atin again is yung mass. Sabi, yung mass, yung radius, at yung ating speed. Okay? So, hindi given yung coefficient of friction dahil wala naman daw dapat tayong friction. Therefore, if we equate these two, we have mb squared rho sine theta is equivalent to mg cosine theta. Right? So, ang hinahanap sa atin is theta. Ililipat ko lahat dito ng theta, and then the other givens will be on this side. So, cosine theta over sine theta is equivalent to mg rho over mv squared. Okay? So, itong cosine over sine is actually a cotangent. Pero I can write this into tangent by simply reciprocating this. I-raise ko to sa negative 1 para ito maging tangent. So, we have now sine theta over cosine theta. I-reciprocate lang natin over mv squared over m gravity rho. Makakancel ko si m. Sine theta over cosine theta is tangent theta, and that is equal to b squared over g rho. Okay? And your theta is equivalent to arctangent negative 1, o arctangent na nga, negative 1 pa, over g, and then the radius of curvature. Okay? This is now your angle or your banking angle, okay? If the velocity of the car is given, the gravity is a constant, and the radius of the curve. So, this is your theta in terms of velocity and radius of curvature. Okay? So, always remember this. Gagamitin nyo to sa topic na super elevation pag kayo ay nasa inyong 3rd year and 4th year level na. Okay? So, this is the formula for the super banking angle. Okay? For sample problem number 2, sabi dito, a 3 kg disc is attached to the end of a cord as shown. So, the other end of the cord is attached to a ball and socket joint located at the center of the platform. If the platform rotates rapidly and the disc is placed on it and released from rest as shown, determine the time it takes for the disc to reach the speed great enough to break the cord. The maximum tension on the cord can sustain is 100 Newton, and the coefficient of kinetic friction between the disc and the platform is mu ito. This is mu sub k, or the kinetic friction is equivalent to 0.1. So, this is the free body diagram of the particle. So, along the normal axis, doon nag-a-act yung tension because of the cord here. So, if we write the axis here, if this is the motion of the particle, pag ganun. Okay? Ito yung N, ito yung B, at ito yung T. Okay? So, hindi lang siya nakatangential. But that is the axis. So, in free body diagram, ito. Sir, bakit po yung friction is along the direction of acceleration? As sabi dito, umiikot daw yung ating platform. So, umiikot ito and then ilalagay ko to at rest. Therefore, uh, yung friction or yung connection between the disc D and the platform, yung magkokos ng motion for disc D. And that connection is the friction between them. Okay? That is why yung ating friction this time is on the positive or in the direction of the acceleration. Okay? So, now, using the three conditions kanina to be satisfied, yun yung gagamitin natin. Okay? So, the three condition is that the summation forces tangential is equivalent to MAT. Okay? Ano yung forces acting on the tangential? That is 0.1 ND or the normal force ND. And that is equivalent to the mass of the particle, which is 3 kg times AT. Okay? We have a value for ND. So, wala pa pala. Okay? So, by summation forces on the B naman, that is should be equal to 0. We have now ND minus 29.43 Newton is equivalent to 0. Therefore, we can say at our normal force is equivalent to 29.43 Newton. So, using this equation 1 and this equation 2, we can get now the value of our AT, which is 0.981 meters per second squared. Okay? Counter check with the calculator. 2.943. No, 0.991. 97. 2943. Ayan, 0.981 meters per second. Okay? And the last condition is that the summation forces on the normal axis is equivalent to the mass multiplied by Nn. By our An is equivalent to V squared over rho. Okay? Alright. So, the summation of forces on the normal is equivalent to T, and that is equal to M V squared over our rho from the figure here is 1 meter. Okay? 1 meter. Therefore, we don't have the value of we have the value of T. So, sabi natin, sabi ng problem, hindi ro dapat ma-exceed yung 100 Newton. So, this is 100 Newton. And we want to get the critical value, BCR. Okay? This is the most critical value of our velocity. Kasi kapag na-exceed natin yung value ng BCR na to, we will exceed the 100 Newton allowable tension. Okay? So, our mass is 3 kg. BCR squared over 1. Therefore, in our case, we get the value of BCR is equivalent to square root ng 100 over 3. 5.77 meters per second. Okay? This is your critical velocity. This is your normal force. And this is our acceleration on tangential plane. Now, as you can see here, our tangential acceleration is constant with a value of 0.981. Therefore, if we want to get the value of time, we can write velocity as a function of time. Velocity as a function of time. Okay? Wherein our final velocity is yung point kung saan siya magi-snap or mapuputol, which is our BCR. And that is equal to the BO squared plus 1 half 80, plus 80 squared. 80 lang pala. Plus 80. Okay, so, ano ba yung may 1/2? Ah, ano pala yun? Sa position as a function of type. Okay, so our BCR is 5.77 squared equivalent. So according to the problem, inilagay daw initially at rest, from rest. Therefore, the initial velocity is 0 plus our acceleration is 0.981 multiplied by the time. So the time to reach this velocity is equivalent now to 5.89 seconds. Okay? And that is our answer for this problem. Next problem, sample problem number 3. This should be the last kasi meron pa tayong isang topic na i-discuss. So, medyo mamadaliin ko na yung mga portions na to, pero ibibigay na lang ako ng mga reference for you to read. Okay? So, sabi sa atin sa sample problem number 3, the sign of ski jump shown in the photo requires knowing the type of forces that will be exerted on the skier and her approximate trajectory. If in this case the jump can be approximated by the parabola shown below, we have the equation of the parabola. Determine the normal force on the 150-pound skier the instant she arrived at the end of the jump at point A. Okay? So, ang sabi sa atin is, sana? If in this case, the jump can be approximated by the parabola shown below, determine the normal force on the 150-pound skier, ang bigat naman ito, the instant she arrived at the end of the jump point A. So, ito yung end of jump, hinahanap sa atin yung kanyang normal force. Okay? Where her velocity is 65 feet per second. So, the velocity at this point is equivalent to 65 feet per seconds. So, also, what is her acceleration at this point? Okay, so hanapin muna natin yung slope at this point to determine the components of the motion. So to determine the slope, that should be y prime. Okay, and y prime now is equivalent to the derivative of y with respect to x, and that would be in our case 1 over 200 times 2x. Okay, so at y is equal to 10, okay, we get the value of x equivalent to, solve the value of x using the y is equal to 10. 200 rather. This is 200. The value of y is 200. Actually, negative 200. 200 alpha equal 1 over 200 alpha x squared minus 200. So, so okay, the value of x is 0 when the value of y is negative 200. Alright? So actually, this is already 0. We don't have to actually solve this. Therefore, y prime is now equivalent. If the value of x is 0, therefore the slope of the curve is 0. So we can assume that at this point, our tangential is andito. Okay? So, i-drawing natin yung free body diagram. So, say andito yung skier, mahirap mag-drawing ng tao. So, ito na lang. Okay? So, ito yung kanyang AN, AT rather. And then, nandito yung kanyang AN. Okay? So, AN is always along the center of curvature. If this is parabola, we can assume that andito yung mga center of curvature niyan. Okay? So, AB na yun, yung B axis ngayon, or the binomial axis, binormal axis ngayon is on this direction. Okay? Perpendicular to the screen. Right? So, andito yung AN, andito yung AT. Ano-ano ngayon yung forces? So, bibinigay ba sa ating, walang ibinigay na, tawag dito, friction. So, we can actually neglect the friction since walang ibinigay na coefficient. So, we have here the weight. So, dito, nag-a-act sa kanya yung weight niya, which is equivalent to mg, and yung ating normal force. Okay? Ano pa? Wala na. Yun lang yung nag-a-act sa kanya. Alright. So, if we take the three conditions, nakalimutan ko yung term na condition. Okay? So, hindi na natin kailangan i-consider yung along the binormal axis kasi walang epekto. Okay? There is no forces acting on this direction perpendicular to the screen. Okay? So, unahin natin yung summation forces acting on the tangential should be equal to MAT. So, there is no force acting on the tangential, therefore this is equal to 0. Our mass, ang sabi dito, binigay ba yung mass? So, unfortunately, hindi rin 150 pounds. So, that is a unit of force. So, 150 pounds is a unit of force and not a unit of mass. So, we have to divide that by the gravitational acceleration, which is 32.2 AT. Okay? So, let's proceed with the normal component of the acceleration. That would be the summation of the forces on the normal axis is equivalent to the mass times the normal acceleration. So, pagdating dito, we have now forces. Yung una, we have N going upward minus mg is equivalent to MAN. Our value of N is still unknown. Our mass is 150 over 32.2. Times 32.2. Wait. So, magka-cancel out lang. I can already use W naman nga pala. Sorry, I forgot. Nasanay ako ng mg. And then, 150 over 32.2 times AN. Okay, so from here, you can solve AN in terms of N. So, we have here N minus 150 is equivalent to 150 over 32.2 AN. AN. But we all know that AN is equivalent to the velocity of the sphere over the radius of curvature. So, we can rewrite this equation as N minus 150 equivalent to 150 over 32.2. And then the value of AN is B squared over rho. So, kunin natin yung radius of curvature dito. The formula for the radius of curvature is 1 plus y prime squared raised to 3 halves over the absolute value of y double prime. Y double prime. Okay? So, the value of x is equivalent to 0. So, kunin muna natin. We have now the equation for y prime. So, kunin muna natin yung equation ng y prime. That would be 2x over 200. And our y double prime is equivalent to 2 over 200. Okay? So, at x is equal to 0, therefore, our y prime is equivalent to 0. Therefore, rho is now equivalent to 1 plus 0 raised to 3 halves over 2 over 200. And which will give us 100 feet. This is the radius of curvature. So 100. Okay? We have the velocity 65. So substitute na natin dito. 65 squared. Therefore, you can solve for n. That is equivalent to 347 pounds. We have to determine the normal force. Ayun na, yung normal force. Okay? So, this is your answer for the normal force. And then, the second question is the acceleration at this point. Okay. So, ang problema is the acceleration. We all know that our tangential acceleration is 0. Okay? So, a t now is equivalent to 0. From here, our an is babalik tayo dito. We have the value of b, we have the value of rho. So, that is 65 squared over 100, which will give us a value of 42.2 feet per second squared. Therefore, our acceleration from using SRSS, square root of the sum of squares, that would be square root of 0 squared plus 42.2 squared, which will yield to an answer of 42.2. 42.2 feet per second squared. This is your acceleration and this is the answer. Okay, so that's it for this topic. We can now proceed with the kinetics of particle, work, and energy. So, ipopost ko na siguro muna dito and then I will continue.